Hello everyone, this talk is about a refined comprehensive earthquake focal mechanism catalog for Southern California, derived with deep learning algorithms. This work is done in collaboration with Professor Zachary Ross, Al Hodgson, and Yehuda Benzain. Earthquake focal mechanisms are primary data for analyzing fault zone geometry, fault slip direction, and the crustal stress field. Traditional method uses the recorded P-wave first motion polarity and the S-wave P-wave amplitude ratios to inverse the earthquake focal mechanism. But for small earthquakes, the phase arrivals and the polarities are hard to be separated from the noise. We overcome this challenge by implementing CNN polarity picker and phase picker that are trained using millions of seismic waveforms in Southern California with high accuracy and high detectability. Here is how it works. Traditional method only uses catalog arrivals from broadband channels and catalog polarities. In our study, we added catalog arrivals at short period channels and additional arrivals and polarities detected by the CNN pickers to the focal mechanism calculation. The right side shows an example. By using more input data, we can obtain a better focal mechanism that fits more observations with smaller focal mechanism uncertainties. Here the dashed line circles denote the nodal plane uncertainties. We applied the improved procedure to all catalog events from 1981 to 2019. More than 40% of the events have at least one additional S-wave P-wave amplitude ratios and one additional P-wave polarity, leading to 42% more focal mechanisms than the standard catalog. Most of the improvements are from small magnitude events and quality B and C focal mechanisms. Before 2007, there were at least 20% more focal mechanisms obtained every year. After 2007, there were at least 40% more focal mechanisms obtained every year. To check the quality of the new catalog, we compared it with the standard catalog to see whether they are consistent or not. We also compared both the new catalog and the standard catalog to see which one is more consistent with the moment tensor catalogs solved using waveform inversion methods. Furthermore, we checked the similarity of focal mechanism solutions of the repeating earthquakes with similar locations and similar waveforms. To check the similarity of two focal mechanisms, we use the following two parameters: Cargan angle, which is the minimum rotation required from one focal mechanism to the other, and matrix angle, which is the dot product angle between two moment tensor matrices of the focal mechanism. Here is the result of the comparison between the new catalog and the standard catalog. Over 80% of the common quality A and B events show angular differences less than 25 degrees, and there is no focal mechanism pair with negative radiation pattern similarity. We then compare the new catalog in green color and the standard catalog in purple color with multiple moment tensor catalogs. Vertical lines show the 80th percentile of the histogram. Overall, our new result is more consistent with moment tensor solutions compared with the standard catalog. Moreover, we checked the similarity of focal mechanisms of 65 events with very similar waveforms. To check the consistency, we plot the axis of maximum shortening, axis of maximum lengthening, and the intercepts of nodal planes of their focal mechanism solutions in the same figure. The first column shows the results from the standard catalog. The second column shows the results from the new catalog. Our new catalog shows more consistent focal mechanisms, less uncertainties, and more solutions. Here are the map views of focal mechanisms in near Southern California and northern Baja California. Our new catalog delineates more details in space and time. So what's new we can find from this new catalog? Let's first look at the Salton Sea geothermal field. We first compare the temporal variation of net production volumes in the Salton Sea geothermal field, which is this black curve, with the percentage of reverse faulting events in the same region, which is a blue curve. The color bar shows the correlation coefficient between these two curves. The new catalog shows a strong correlation between net production rates and the percentage of reverse faulting events, which suggests that the net production may reduce the overburden pressure, perturb the stress balance. Then the horizontal stress pushes the hanging wall to move up and generate reverse faulting events. We further check the temporal variations of the focal mechanisms near the 2010 MIL Cucapa earthquakes along AA prime. The upper figures show the focal mechanisms colored by p-axis azimuth. The lower figures show the faulting types. Before the main shock, these two catalogs share similar patterns, with mainly north-northwest, south-southeast oriented p-axis azimuths and mainly normal faulting events. After the main shock, the new catalog show more northwest-southeast oriented p-axis near the Sierra Cucapa fault and more reverse faulting events, suggesting more significant stress rotation after the major rupture. The new catalog also provides new insights in the fault zone structure. We checked the nodal plane orientations of focal mechanisms in the southern San Andreas fault zone. The new catalog shows less north-south oriented nodal planes and more near vertical nodal planes compared with the standard catalog. Here is a summary. We added additional CN arrivals and CN polarities into focal mechanism calculation and obtained overall 42% more focal mechanisms. The new catalog shows improved quality with over 80% quality A and B events, showing angular differences less than 25 degrees compared with the standard catalog. The new catalog is more consistent with moment tensor solutions compared with the standard catalog. And for repeating earthquakes, the new catalog shows more consistent focal mechanisms, less uncertainties, and more solutions. Here are some new discoveries from the improved catalog. We observed a strong stress rotation in the Sierra Cucapa after the 2010 magnitude 7.2 MIL Cucapa earthquake. A significant positive correlation between the net production rate and the percentage of reverse faulting events in the Salton Sea geothermal field, as well as more near vertical active faults near the southern San Andreas fault zone. Thanks for listening, and here is my contact info. Welcome further discussion and hope you enjoy the AGU meeting.